the next topic we are having, that is axis of rotation, or you can say that as a axis of location. What does it mean? It means that if a body is in translational equilibrium, we are talking about the first condition. Okay, as you guys all know, in the previous video I've discussed about the conditions. One, if the body is in first condition, we are calling as a translational, so we are calling that, we are talking about in the first condition. If the body is in translational equilibrium, so as you guys all know, the net torque is 0. Okay, so net torque is 0 at a given point. At a given point must be 0 at any other point, which means that the net torque is 0. But at any other point, if you're talking about the center point from this to this, that net torque is 0 here. So which means that here the net torque will be also 0. So for that we are having equation to check that on other point the torque is 0 or not. Let's see. In this video we will be discussed, so you can easily will be familiar with that, not net torque is 0 or not. Okay, so here we are finding that, as you guys all know, in the first condition we were having the sum of all the forces we are having, that is 0. Let me make the diagram first. So this, I am having two bodies here, and here this is the center, and this is a weight, downward weight, and here I am having a force, that is up thrust force F1 F2. These both are up thrust force. Okay, if we talk about the half of this, so we can say that L upon 2, which is half of the length. This length is a half, L upon 2, L upon 2. Okay, and this is all the length. So as you guys all know that net force, sum of all the forces is 0. To check the net torque is 0 or not, so for that we are having this equation. Okay, so here you can see that this, we are x is 0, we are having the y forces. So for y, sum of all the forces y, we are having F1 and F2, F1 plus F2. Here the weight is there, so we can minus weight, that will be equal to the 0. Equation number 1. As you guys all know that net forces, all the net forces are 0, and sum of all the forces is 0. So we can write here that this is equal to the 0, because these forces are equal to 0. So we are having a formula of the torque, that is R multiplied by F, which means that force, you can say that F1, and length, that is L upon 2, L upon 2 multiplied by F2 multiplied by L upon 2. Okay, so this is common, so I can write here, and F1 multiplied by F2 is equal to the 0. Fine. After that, here you can see that here this one will multiply by this, L upon 2 multiplied by 0 is equal to 0. So we can write here that F1 multiplied by F2, that is will be equal to 0, L upon 2 when it will multiply. So we can write here that F1 minus F2 is equal to the 0. Okay, so this will multiply by 0, that will be get 0 automatically. So these both values will be, of course, will be equal to the 0. So this is equation number 2. Okay, after that the equation that we have to find, that is basically that on another, this is that in the center you of a point the torque will be 0. But if we talk about that, what about an other points, there the torque will be 0 or not? For that we are having this axis of rotation. For example, I am having this point here, and this is, I am considering that is the x, this is distance, and that is I am giving the point P. This is I am taking the axis of rotation. Axis of rotation I am taking here, and to another point. So here the torque will be 0 or not? That's the thing. Okay, so here we are having x, so I can write here that will be multiplied by x, and that will be also multiplied by x. Okay, that will be not multiplied, that will plus by x, this will be minus by x, because here we are having the anti-clock rotation, and here we are having the clockwise rotation. So here I can write it, this is plus 1, this is minus. So after that we are having that, as you guys all know, that torque is equal to the R multiplied by F, and here we are having the F1 L2, which is force, this is distance, force, distance, this multiply by F2 L2 plus x. Okay, and here we are having W plus x, I can write here plus WX, this is a distance. So F1 L2 minus F1 x, F1 multiplied by this, F1 multiplied by this is this. Then minus F2 will multiply by this, so F2 L2. Then after that this one plus minus minus. So here for example this is, sorry, so this is minus sign. Okay, so plus minus minus. Okay, so F2 will multiply by x, there will be the F2 x plus this one WX. Okay, so here you can see that we are having that we have F1 L2 minus F2 L2. We have considered these values separately, and then F1 x and F2 x plus WX as it is. Okay, so here we can write here the you can say that common is L2 here, and F1 minus F1 minus F2 minus, we are having the common here, that is x is common, so we can write here that x is common, and F1 minus F2, x is common, we have written here the F1 and F2 is here, then only the W is remaining, so we can write here plus minus, minus plus minus, so we are having the here the W. So as you guys all know, I have discussed that F1 and F2 will be 0, so we can write here this is 0, this is equal to 0, so we can write here that 1 upon 2, that is 0, okay, minus x, and this is 0. Okay, so I can write here that the torque will, this will multiply by 0, x will multiply by 0, so that will be 0. So here you can see the torque will be 0, which means that the translational body in rest is always always 0. At another point the torque will be 0, rather it is here and here, the point torque will be 0 when the body is in rest. So for this we are having this whole equation to understand you guys that the torque will be 0. So that is called the axis of rotation, where the translational body, the net torque is 0, but at any other point the torque is 0 or not, for that this is confirmed that at another point there will be the torque will be 0. So the definition will be more clear, the net torque is always 0, but given point must be 0. At any given point, at any point the torque will be 0 when the body is in translational equilibrium state. Okay, so this was our topic.